Here we're being asked to find the limit as x approaches 2 of f of x plus g of x given the graphs of f and g of x. What we're going to do is evaluate both the left-hand limit and right-hand limit for these functions. So we're going to put a plus here and a minus here. This is going to be our right-hand limit. This is going to be a left-hand limit. Let's start with the left-hand limit and ask ourselves, what's the limit as x approaches 2 from the right of f plus g? You might look at this graph and say, well, look, it seems to be broken, right? And because it's broken, it's got to be discontinuous. Well, while it is true that f itself is discontinuous and g itself is discontinuous, their sum might not be. So let's have a look. As we approach 2 from the right of f, we see we approach the y value of, looks to be 1, 2, 3, 4, 5, 6, 7. As we approach 2 from the right on g of x, we seem to be approaching the y value of negative 3. Let's do the same exact thing, but approaching from the left. As we put our pencil on the curve of f and trace from the left, we approach the y value of 5. So we could have 5 here. Oh, I think I put this in the wrong spot. That's okay. Let's move this around. This would be 7 and then minus 3, and I said this was 5. As we approach from the left, we're getting, on this graph, negative 1. Now, do these come out to be the same thing? Well, they sure do. 7 minus 3 is 4, 5 minus 1 is 4, and so the two-sided limit is 4. So despite the fact that these two graphs are broken, that f is broken here and g is broken here, the sum ends up being the same number in both cases, so our overall limit is 4.